Hello, my name is Evan Bullion, and today I'm going to walk you through a brand new interface for QIIME 2. This is still an alpha release of it, so there may be things that don't quite work, and this installation process is going to be a little bit bumpy, but this is something we hope to improve in the future. So just kind of bear with me as we go through this process. So we have a interface which can actually generate Galaxy tool descriptions. If you're not familiar with Galaxy, it's a really cool project that provides a graphical interface for using different command line programs. System administrators like it because they can manage a central deployment, and users like it because they don't have to usually worry about the technical details. Now, if we're using this, we probably don't have that centralized deployment just yet, because again, this is very new. So some of these things are going to kind of be something that more traditionally would be the system administrator's job. Fortunately, the world of development operations and deployment have made this relatively straightforward, but there's going to be a bunch of tools that we're going to use to make this happen, and so that's why I wanted to create this video to kind of help people out. So I'm going to start with using what's called Docker to install this. So Docker is a way of running a virtual machine, basically. And I'm going to do this in a Windows environment. If you're on a Linux environment, Docker is actually very straightforward to use, and there's a lot of examples online. If you're on Mac, there's going to be a tool called Docker Desktop, which is what I'll be using here on Windows. And so some of these things are going to look the same, and some of them are going to actually be easier on Mac as well. But Windows is probably the most challenging environment to use Docker in at the moment. Now, this is something that has been improving over the years, so expect this to get better. So the first thing we're going to do is we're going to install Docker Desktop. I've already done this, but you want to basically navigate to the appropriate install instructions for your operating system. So on Windows, you would click here, and this would be your installer. Some details: it is going to prefer the Windows subsystem for Linux version 2 backend. This runs a bit faster, but you do need to have these particular hardware available. So this is a little bit technical, but most modern computers are going to have this available. If you have perhaps a very old laptop or something, it may be the case that you'll be unable to do this. In which case you may be able to use the Hyper-V, although actually disregard that, it requires basically the same hardware. So if you have a modern Windows machine, you'll be able to use this. So I've already installed Docker, and it goes through kind of two processes where you install Docker and then it creates another installer to install Windows Subsystem 2, and there's some configuration required. It does give you instructions the whole way through. It's relatively straightforward, but it is a little more complicated than most program installations. Once it is completed, you'll have this little Docker icon in the bottom right in your taskbar. So if you open that, you can see a dashboard. And so if you have Docker installed, you should be in a kind of a position where you have no containers running, you have no images, and don't worry about this. This is new to me as well. And to confirm your settings, you can click this gear up here, and we can look at how Docker is actually running. And so I'm using the WSL2 based engine. It does work a little bit better, but there's a few caveats that we will get into. So the next thing we're going to do is actually pull an image. And so our image lives on QIIME. It's under the QIIME 2 organization, and the image is specifically Q2 Galaxy. So this Docker image is going to contain a Galaxy deployment as well as the tools that Q2 Galaxy has templated. So to run this on Windows, we need to open PowerShell. So I'm going to type in PowerShell into my Windows prompt. And so now I have this lovely blue command prompt. And so if you haven't used PowerShell before, it's kind of the next generation of command prompt for Windows, but it's very different from Bash. So if you're familiar with Bash on like Linux or Mac systems, this is just an entirely different shell. But we can still run these style commands. So I'm going to say docker pull QUIIME QIIME 2 Q2 Galaxy. And it defaults to latest tag. If in the future these instructions change, you might notice a colon at the end of this saying some particular release, but for the moment we're just uploading these as latest. And so what it's doing right now is pulling all of the intermediate layers that build this operating system, and it can do that in parallel because they're for the most part unrelated. So this will take a little bit. Looks like we're just about done, at least with the download. So while that runs, I'm going to show you where to learn more about how to use this particular image. So you may notice this relatively scary command at the bottom. What it's doing is it's assigning different host resources to the container inside. If we want to learn more about it, our image is based on this Docker Galaxy stable image, and it has some pretty comprehensive instructions. One of the things that's going to be important here is making it so that we can persist our data. And so on systems that aren't Linux, it's a lot faster to store your data in actually what's called a data volume in Docker. And so this is an example of creating a data volume and then using it. We're going to do something a little bit different, but the idea is the same. What's important, though, is this particular container uses what's called an export directory. And this is where it's going to store the database, all of your outputs, all of your Conda environments. So this is basically the persistent state of your Galaxy deployment. And so our goal is to store this export directory in our container on the host system somehow. So let's have a look at where we are. Okay, so we have downloaded that successfully. And if we go look at our dashboard, we should see over in images, there's this new image here. And you could run this as is right now, but you won't be able to talk to it until we configure it, and you also won't have any data persistence, which is kind of important. So the next thing we're going to do is we're going to run a command docker volume create, and then this can be pretty much any name you want. I'm going to call it Q2 Galaxy data. So that runs and it gives us the name back. And this is somewhat annoying, but it's kind of the workaround I've found that works. We're going to say docker volume inspect Q2 Galaxy data. And we are looking for this mount point here. So this is the location that the data is stored inside of this volume. And so when we go back to actually run this over here, we're going to need this path. It is possible to basically connect that export directory to like your desktop or something, but it takes forever. So I ran it for like about 2 hours and it still hadn't finished. So this seems to be the better workaround. And I am trying to remember how to copy and paste. On Windows, it's Control-Shift-C. So now what I'm going to do is I'm going to hit this run. And importantly, I'm not going to just start there. I'm going to change these optional settings. So the container name's not too important, but we'll call it Galaxy. Then for the ports, and I apologize that it's in this order, but we need to hit the plus button a few times until we see 80 TCP. So that's how our browser is going to talk to Galaxy. And so I'm going to map that to 8080. That's a pretty common mapping. And then over here is where we're going to connect our data. So this is where we need that var lib docker volumes, whatever you named it, underscore data. I copied it, so I'm going to paste that in. And then we're going to connect it to the export directory in the container. So that is /export. So again, this is the root directory, and then there's just something in the root called export, which is where this image is programmed to put all of its persistent data. So once that's there, we can run. And if we click on if we go to containers and apps, we can click on this image. Whoops. If we click on the kind of square itself, we can see the log. The log is really pretty messy for this image, but once it's finished checking export, it'll start actually running. And so because this is the first time we've run it, it's actually generating a bunch of data in this directory, which will then be stored in this data volume for persistence. So this will take a little bit. Okay, so it has populated an initial export state, and so now it's installing some basic tools. This doesn't take too long. Soon we'll see a bunch of pip installs, and we're really just waiting for the web app to start logging. And those logs look pretty complicated, but they're nothing to worry about. So we're now starting the Galaxy web app here. Take a little bit longer. Okay. So now we're seeing logs that look like they're coming from a web server. You can see we're serving a number of things. And so what we can do now is, because we left those other ports blank when we configured it, we can just hit this Open in Browser button. And here is Galaxy Docker. And it's pre-configured to have all these different QIIME2 tools. But something that we need to do first is upload some data. So this interface doesn't yet know how to import anything. So you'll need to start with your own QZAs and your own metadata files. This is something that we're obviously going to improve, hopefully in the next release, but we just wanted to get something out there. So I'm going to choose some local files. I'm going to select that. And so this is our Atacama metadata from our tutorial. And the reason I'm doing this is because before any of these tools run, Conda has to actually set up an environment for the tool. And this actually takes some time. So I'm basically picking the simplest action I can do, which is going to be metadata tabulate. So I search tabulate in here, I select that, and so it's already filled in. It knows it can use this as input. So I'm going to hit execute. And if we go back to our Docker log, we're going to see, scrolling down, here we go. So Galaxy is now going to solve for this environment. And so you may be aware that installing QIIME2 takes a little bit of time. And so it's going to take about the same amount of time here. So we're going to wait for that. Something I do want to say is, if you notice the log is starting to try and solve smaller versions of these, so like maybe it's trying to solve for just Q2 vsearch, you probably had an internet timeout when it was trying to create this full environment, and so something's gone wrong. In that case, it's actually not going to complete, but it's going to spend quite a while trying to find a resolution. What I would recommend is stopping your container and just restarting this process. So we're going to wait until this is finished. But once it is finished, all of the other QIIME2 tools are going to use the same environment, and so you won't have to do this again. Also, this environment is going to be saved in the export directory that we have mounted, so it will persist between multiple runs. So I'm going to cut the video here, and I will rejoin once this environment has solved. Okay, so it looks like that environment got set up, and we can see that we are running a job. That's also evident over here, and it completed. So that's a good sign. If I wanted to look at this, I could download the file. So if I were to save that, Galaxy does name it in a pretty interesting way, but it does work. So here's what I downloaded, and here's our metadata. So that's pretty straightforward. And if we were to rerun this, So if we hit this little rerun, we can change things about this. So maybe, I don't think this parameter matters too much, but maybe we double that. We execute. It's not going to install the conda environment again. Instead, it's just going to start the job. And so it's really just the first job you do is going to take a while it sets up that conda environment. What I would recommend doing at this point is once that job finishes, which will take a moment, verify that your data is in fact persistent. And the way you do that is you're going to just hit the stop button here, which is going to shut down the container. And so if we look at this view, we see that this is no longer the nice green, it says exited. And if we start it again and have a look at the log, we're going to see it basically start over. So these were the first 2 lines last time, but it's going to check the export. And what we want to see is that it recognizes all of the data we've created and the environments we've constructed so that we know that we're saving our data correctly. If our history ends up being empty and we don't see anything that we set up, then we might want to figure out kind of what went wrong. That way we don't accidentally lose some data. And you see that went relatively quickly because it realized it was already set up. And so now it's just starting the various servers that set up this Galaxy deployment. So I'm going to wait for that to finish, and then we will see if we still are using, for example, 2.3 megabytes and we still have this data. I haven't refreshed the page yet, which is why this is all still here. It's the wrong window. Okay. So it looks like the Galaxy server is just about starting to boot up. We're starting Node.js. I assume that's for client code. Okay, looks like we're running. So I'm going to shift refresh this just to prove. And here we are, and we still have our history. So our data is successfully persisted. And so what you might want to do at this point is actually run some kind of analysis. So I'm going to throw some QZAs up. Remember, at the moment, importing is not supported. We have a plan for that. So you should be able to expect it probably in the next release. But for the moment, you'll have to import on the command line, kind of like you do right now. Oh no, this is unusual. So I got an error, and I'm not quite sure what's wrong, so I'm going to click View or Report this error. That doesn't clarify much. Let's see if Details knows anything. Got exit code 1. If I look at standard out, there's nothing there. Standard error, still nothing. So what I'm going to do is not worry too much about that and just try uploading it again. So that was this file. It is running. There we go. So I don't know what went wrong. I'm not too worried about it though, and I'm going to delete this from our history. So I have some rep seeks and I have a table, and you'll notice the type and UUID are listed here. And I might zoom in a little bit so that's more obvious. And so Galaxy is recognizing that these are QIIME2 artifacts. And what that means is we could do something like, let's say we're going to calculate Jaccard. But before that, we probably do want to rarefy. And so we might set a sampling depth here. I don't actually remember what a reasonable one is. So let's calculate, let's visualize this. So what is that? Summarize. So feature table summarize, that looks good. So it accepts these kinds of tables, and then we can provide some sample metadata as well. So I'm going to execute that. And I realize I'm using the Atacama tutorial. I don't use this very much, so I don't exactly remember what we're going to see here. This may prove to be a terrible example. We'll find out. But we'll wait for that to run. Okay, so we have our table, we provide some metadata, and so I'm going to download this by clicking the I, save that, and then let's go ahead and use that result. Okay, that's actually a pretty nice distribution. If we go over here and we look at something interesting like I'm kind of looking for something like elevation. That's nice. So yeah, it looks like we can sample. I don't know. I'm going to pick arbitrarily. This is actually not sequenced very deeply at all. You know, I'm going to just say 300 for the sake of example. Maybe that's not the best result, but it seems reasonable. So I could then rarefy. I'm going to put in 300. Oops, that's 400. And then I'm going to see if there's anything else I care about. I'm going to keep this as no. So we'll execute that. And while that's running, I'm going to point out that the Galaxy interface is able to identify what invalid results might be. So if I put in a 0, it says it's out of range and has been autocorrected to 1. If I put in -50, it does it again. So that's nice. And then let's suppose we want to compute Jaccard on this table. So I'm going to use a plugin DiversityLib directly to calculate this. And so Galaxy's already recognized that that particular table can be used here. And then I'm going to select some additional options. And so here's something I want to highlight is we can handle these complex parameters, such as providing the number of jobs we want to use. And so I'm actually going to change this to auto instead of providing a value. So this will use as many resources as it can find. So I'm going to execute that. This is such a small table, there's really no need to worry too much about parallelization here, but I wanted to use it as an example. And there we are. So we might do something like, I don't know, beta group significance. Seems reasonable. Maybe beta correlation. Let's do that. We don't usually do that. And so here we can select a metadata column. And so it's already found that this is pretty much the only file that makes sense here. And then I'm going to do elevation. I think sounds reasonable. These seem fine. Yep. I'm actually going to call this Jaccard. And I'm going to call this elevation. So I will execute that. And so now we get two visualizations that are going to be computed, or I'm sorry, we get a QZA and then a QZV. And then we'll have a look. I don't expect this to be terribly groundbreaking, but it's a demonstration. That did not work. The following IDs are not contained in both distance matrices. This sometimes occurs when mismatched files are passed. You can use intersect IDs. Well, that sounds good. So I'm going to hit the retry. And then it sounds like there's an option here, intersect IDs. I'm going to say yes. And it filled in all of the same parameters we had before, so I don't have to relabel elevation or Jaccard. So I'm going to execute again. Maybe this will work better. It's also quite possible I've downloaded the wrong table entirely, but we'll find out. Actually, this makes sense because I ran a rarefy step, which is going to drop some samples. So the metadata is not going to match up exactly with our rarefied table. And so here we are. So I'm going to take a look at this QZV. I'm going to save it. And then, okay, so now I'll go back to view.qiime2.org, put that in, and here's our result. So apparently it's significant. I'm not sure I like the look of this so much, but again, this is just a test. So going back to Galaxy, that's kind of how you use Galaxy and QIIME 2 inside Galaxy. So hopefully that was straightforward enough. I realize working with Docker is a little bit complicated, but it's pretty exciting that we get to run QIIME 2 in this graphical interface on Windows.